topic is integration. Integration is antiderivative. That means it is the opposite of derivative. In integration, we find the area of the curve, where in derivative, we were finding the slope of the curve at a point. Now, how to find area of a curve? In case of straight line, it was very easy to find the area by using the formula of triangle or by using the formula of trapezium. But in case of curves like this, how could you find the area? It's very difficult. For finding area of such curves, integration is used. How it is used? Let's assume that we are finding the area of this curve from this point to this point. Okay, this is x1 comma y1 and this is x2 comma y2. To find area of such curves, we need to break this part into small rectangles. Like let's assume this to be a rectangle, okay, of breadth dx and height is y1. You can see that a small triangle is getting omitted. To reduce this omission, we take the breadth to be dx. We know dx is a very small number, so this triangle is not getting omitted. Now we assume this area to be dA. dA means very small area. Area of this part dA is y1 dx, isn't it? The height is y1 and the length is y1 and breadth is dx. Let's assume area of this part to be dA1. Okay. Now if I divide this part into more such dA and name them as dA2, dA3, dA4, so the area of this part would be dA1 plus dA2 plus dA3 ... I am just changing these points to xn, yn. Let's assume that this area is divided into n parts. DAN. All the parts are very small, so we can write DAN or DA3, DA2. Okay. So here we can see that we are adding the areas, and when there is addition, we can write it as summation of I is equal to 1 to n d a I. Okay, we can write it in this way, which is equals to summation of I 1 to n y I dx. Y is a function of fx. Okay, so we can write over here, this is y is a function of fx. We can write over here summation I is equal to 1 to n f of xi dx. Okay, we can write in this way. This can also be written as integration x to the power integration x1 to xn fx dx. This is how this can be represented in the form of integration. In the beginning of this video, I have said that integration is antiderivative. I will certainly justify this statement, but before that, just have a look at these formulas. These are the integration and derivative of some important functions, among which the important ones for integration is this one, this one, this one, this one, this one. These are important for physics. The rest, tan x, cot x, sec x, you can see that the integration is coming in terms of natural log. These are important in mathematics in class 12. I have written this so that you can compare it with the derivative part. Here tan x derivative is sec square x, and here integration of tan x is ln sec x. In derivative, the important ones are this. This is not important because this is same as the previous one, where n is equal to minus 1. When n is equal to minus 1, then the derivative comes to be minus 1 x to the power minus 2. And since it's x to the power minus 2, then it will come to the denominator as x square. In derivative, this is important, this is important, this is important, cos x, tan x, cot x, sec x, these are important. And in next page, we can see the derivative of e to the power x and integration of e to the power x are same. This is important. And in derivative, ln x is important and cos x is also important. These are not so important in physics. Why integration is antiderivative? Now, in the previous page, I have shown you all that integration of x to the power n dx is x to the power n plus 1 by n plus 1 plus c. Now, what is this c? This c is there in all the integration I have written in the previous page. This c is a constant. This c is a constant which is generated while you do the integration. Why this is generated? When we derive any function which has a constant added to it, it vanishes. We have seen in the first video, that is in the derivative video. So on integrating a function, we get a constant. This is only seen in indefinite integral. What is indefinite integral? See, I have not written any number over here. At the beginning, I have shown that the dA1, dA2, there in that integration I have shown that limits are from x1 to xn. Do you remember that? Just have a look at the first page. Here I have written x1 to xn in this integration. This integration is called definite integration. And in indefinite integration, that is when there is no limits given, we get a constant. Actually, in definite integration, we get constant, but it cancels each other. It cancels when you put the values of x1 and xn. In the previous one, you have written x1 and xn. When you put the values to the formula, then the constant part gets cancelled. But in case of indefinite integral, since it has no lower limit and upper limit, we have to write a constant along with the answer. Okay. Now, I am multiplying this n plus 1 on both the sides. So we get n plus 1 integration x to the power n dx, which is equal to x to the power n plus 1 plus capital C. I am writing it capital C, where capital C stands for small c into n plus 1. Okay. N is a number, any number. How? Very important thing. This integration has an exception. That is, n can never be minus 1. because if n is minus 1, then here minus 1 plus 1 would come to be 0, which is infinity, and area can never be infinity. So an exception to this form is n can never be minus 1. If n is minus 1, then x to the power n would be 1 by x, whose integration is ln x, which I have already said in the previous page that 1 by x integration is ln x. Okay. Now let's come back again. Here I have multiplied n plus 1 on both the sides, and capital C is small c into n plus 1. So since n plus 1 is a number, so c into n plus 1 would be another new constant, right? So I have just replaced small c with capital C. Now I would replace n plus 1 with k. I would replace n plus 1 with k, so n would be k minus 1, right? N would be k minus 1. Now I will put the value. N plus 1 is k integration x to the power k minus 1 dx, which is equal to x to the power k plus constant. Since k is a constant, I can write this inside the integration. K x to the power k minus 1 dx is equal to x to the power k plus c. Now if we find derivative of x to the power k plus c, we will find the answer to be k x to the power k minus 1, isn't it? So you can see that k x to the power k minus 1 integration is x to the power k plus c. So you can see that the integration is coming just opposite of derivative. So this is the reason why integration is called antiderivative. Let us assume small fx to be a function and capital Fx its integral. So we can write it as capital Fx is equal to integration f small fx dx. Okay, that means if we differentiate capital Fx, we will get small fx, that is f dash x is equal to small fx, right? I would like to use the same example, that is capital Fx is equal to x to the power n plus 1 by n plus 1. Okay, this is capital Fx. Then if I differentiate capital Fx, I will get small fx. So I will differentiate the function. Therefore Fx is equal to f dash x, that is d dx of x to the power n plus 1 by n plus 1. Sorry. Now see here, n plus 1 is a constant. So we can take that constant out of derivative. So it would be 1 by n plus 1 d dx x to the power n plus 1. Right? Let us again convert this n plus 1 to k. That is n plus 1 is converted to k. Then n is equal to k minus 1. Therefore fx is equal to 1 by k d dx of x to the power k. Now we know what would be the derivative of x to the power k. It would be k x to the power k minus 1. We will cancel the k's and k minus 1 is 1, so we get x to the power n. So here you can see, on differentiating x to the power n plus 1 by n plus 1, we are getting x to the power n. So on integrating x to the power n, we would get x to the power n plus 1 by n plus 1. let us discuss the basic properties of integration. There are many more properties, but I would like to discuss only 4. Rest you will get to know in class 12 under mathematics. The 4 properties which I would discuss, among which first 2 are similar to that of derivative. Let's just have a look at it. The first property says that if a constant is multiplied to a function, then during integration we can take that out of the integration. You can see here that a is multiplied to gx, and while doing integration the a is outside of the integration. The second property says that if a function is sum or difference of 2 or more functions, then integration of that function is same as the sum or difference of integration of individual functions. Here I have used gx and hx, but there can be more than 2 functions, and this property is applicable in that case also. The third and fourth property need explanation. I would explain it with an example. The third and fourth properties are applicable in case of definite integral only. Here it says that integration of fx dx from limit a to b is same as negative of integration fx dx from b to a. I will explain this with the help of an example, but before that just have a look at the fourth property. The fourth property says that integration of fx ds from a to b can be split into 2 different integrals with respect to a point called c, which is in between a and b. Here it says that integration of fx ds a to c plus integration of fx dx c to b. This is same as integration of fx dx a to b. Now, how is this possible? I would explain both the properties with the help of one single example only. Let fx is equal to x. So integration of x dx from 0 to 3. I am taking the limits 0 to 3 is equal to integration of x would be x square by 2, because here n is equal to 1. So n plus 1 would be 2, and it comes x square by 2. We need to write a box, and on the lower side you have to write the lower limit, and on the upper side you have to write the upper limit. So this is how we should write the next step of integration. Now put the values of 3 and 0 in this x. 3 square by 2 minus 0 square by 2, which is equal to 9 by 2. Now I will find the integration of 0 to 3 minus x dx. Okay, 0 to 3 minus x dx. The integration would be the minus would be outside. Box x square by 2 0 to 3 is equal to minus 3 square by 2 minus 0 square by 2 is equal to minus 9 by 2. Okay. Now I will find the integration of 3 to 0 x dx. The answer, this thing would be the same thing, x square by 2, but the limits would change. It would change. Here it will be 0, it will be 3. So it would be 0 square by 2 minus 3 square by 2, which is equal to minus 9 by 2. Here we can see that both the answers are coming to be minus 9 by 2. So just to remove a negative sign in front of an integral, we can change the upper limit and the lower limit. This would not affect the answer. Now I will explain the fourth property using the same function fx is equal to x. I will integrate it from 0 to 3 x dx. Now I am taking a point in between 0 and 3, that is 2, and I will split this integration into two parts, 0 to 2 x dx plus 2 to 3 x dx. We have seen in the previous example that is 0 to 3 x dx integration is 9 by 2, and here it would be same x square by 2 from 0 to 2 plus x square by 2 from 2 to 3. So this will be 2 square by 2 minus 0 square by 2 plus 3 square by 2 minus 2 square by 2. This would be 4 by 2 plus 3 by 2, 9 by 2, 9 by 2 minus 4 by 2. This 4 by 2 and 4 by 2 will get cancelled, and the answer would be 9 by 2, which is same as this one. Now I will find the area of the straight line y is equal to x plus c. Now by using the formula of trapezium, area is equal to half into sum of the parallel sides. Here it's 3 and here it's 6. 3 plus 6, sum of the parallel sides into distance between the parallel sides. Here it is 3 square units. Half into 9 into 3 square units, which is equal to 27 by 2. Now I will use integration. Area is equal to integration 0 to 3 x plus 3 dx. X can be considered as separate function and 3 can be considered as separate function. So we will use the second property, 0 to 3 x dx plus 3 integration 0 to 3 dx. Okay, x integration x square by 2 0 to 3, and since this is a constant we can take this out, and 3 into, we can write this as 3 into 1, and what is 1? 1 is x to the power 0, so it's x to the power 0 dx 0 to 3. So this can be written as 3 square by 2 minus 0 square by 2 plus 3 box x from 0 to 3. This is equal to 9 by 2, this would be 0, plus 3 minus 0, so I am writing 3 into 3. That is 9 by 2 plus 9. Now on simplifying this, 9 into 2, 18, 18 plus 9, 27 by 2.